Your paper, go ahead and put down that this is page 3. We are on page 3. We are starting with our integer rules. As a reminder, we are recording because your class is the one that I have to record each time because of the other class having lunch in between. So your class is being recorded right now, so make sure that you are listening carefully and following directions. Integer rules. So I'm just going to go over the basic rules that you guys should have learned from 6th grade. In 7th grade, you do get to use a calculator at all times, except for a small portion on the milestones is calculator free. And those typically are going to be your positive and negative numbers with addition, subtraction, multiplication, and division, your fractions and decimals. But it's only like 7 to 10 questions. So we're just diving right in. We're going to go over the rules very quickly, and then we're going to focus mainly on word problems. My table in the back, if you could keep your talking to a 0, that would be great. So our addition rules, when you are adding integers, some teachers like to teach it with the song, the same signs add and keep, different signs subtract, keep the sign of the larger number, then you'll be exact. I'm not about that singing life though, so. So we're going to go ahead and write that rule down. When you are adding your integers, if they are the same sign, then when they say you're going to add and keep, you're basically meaning you're going to add the numbers together. And then you're going to keep the sign. So whatever the sign is. If both numbers are positive, the answer is going to stay positive. If you're adding 2 negative numbers together, then you're going to keep your answer as a negative. So, a couple of examples. Like normal, you know that if you take 3 and add 4, they're both positive, so therefore you're just adding 3 and 4 together, and it's going to give you a positive 7. But if you were to add 2 negatives together, so let's say negative 2 plus negative 6, it's the same idea. You're adding the 2 and the 6 together, which would give you that 8. But because they're both negative, then your answer is also going to be a negative. I'm not going anywhere. So when there's same signs, you just add the numbers like normal, keep the sign of whatever the problem is. Keep the sign. Different signs. So I'm going to do this in blue. For your different signs, you're going to go ahead and subtract. Meaning you're going to take the higher number, and subtract the lower number, not the higher value. Remember, positive and negative represents the value. We're just focusing on the base number. So you're taking the higher number and subtracting it by the lower number. And then you'll keep the sign. Keep the sign of the higher number. So if the higher number was positive, your answer will be positive. If the higher number was negative, your answer will be negative. So a couple of little examples. We've got negative 4, and we're going to add 7. Then essentially all we're going to do is take the numbers, the 7 and the 4, that's him doing a science experiment. We're just going to take the 7 and the 4 and subtract them. And then because of the fact that the 7 is a positive, that means our answer is also going to be a positive. The higher number was positive, so our answer is positive. If we had negative 8 plus 2, again, you're just going to focus on the numbers and subtract them. They're different signs, so you're really going to subtract them. You're going to take 8 minus the 2, and because the 8 was negative, your answer, which was 6, is also going to be negative because the 8 was a negative. Now, it would be no different than if I were to go ahead and say, let's say these green pins. These green pins represent my positives, and then all of these pinks represent my negatives. How many positives do I have here? 3. How many negatives do I have here? 4. Now, if I want to combine this together, can I just say, oh, it's 7? No. For every positive that I have, I can take a negative, pair it together, and they 0 pair out. So there goes one pair. Here goes another pair. Here goes another pair, and I'm left with one what? What was the red again? Red was negative, or pink was negative. So that's essentially what's happening. When you're trying to combine positive and negative numbers together, you're really taking things away instead until you're left with either a certain amount of positives or a certain amount of negatives left over. Whichever one you had more of to begin with. Look, I've got 8 negatives and 2 positives. So that means I've got 6 more negatives than I do positives. That's essentially all you're doing. It's a subtraction problem. Even though it's essentially here an addition problem, it's really subtraction. Alright, so speaking of subtraction, let's talk about what to do when you are subtracting integers. It's okay, it's still there. It's just going to get moved up a little. So for subtracting integers, we do a little something called additive inverse. It means that we're adding the opposite. Additive is addition, and then inverse means opposite. That's in my green. Additive inverse is just the idea of adding the opposite. So in other words, you might have seen it before from your 6th grade teachers. They called it keep, change, change. So in parentheses, I'm going to put keep in green, change in blue, and another change in pink. Keep, change, change. So when you are subtracting, subtraction problems are really just addition problems. All subtraction problems are addition problems. Every subtraction problem can be transformed into an addition problem by doing keep, change, change. So if I've got the problem negative 15 and I want to subtract 2, negative 15 minus 2, I can break this up into an additive inverse, where the first part I'm going to keep. So I'm going to keep my negative 15. Then that operation, I'm going to change it. What am I going to change subtraction into? Addition. Thank you. Subtraction can be changed into addition. All subtraction problems are additions of the opposite. So then I'm going to take my second value and I'm going to change it to the opposite. So what's the opposite of 2? Negative 2. Thank you, Braxton. Negative 15 plus negative 2. Negative 15 plus negative 2. So it's essentially like saying, hey, I've got 15 pink markers and I've got 2 pink markers. Can I count those pink markers together? Yes, because they're all pink. So if I've got 15 of them and then I've got 2 more of them, how much do I have? Negative 17. So you're just following that addition rule of same sign. They are the same sign. So you're going to add and keep. Negative 17. When they're the same sign, you add and keep. Let's try another one. Negative 5 minus negative 4. Negative 5 minus negative 4. So we're going to start off with the first one. The first number, negative 5, we get to keep. Remember, the rule is always keep, change, change. So we keep negative 5 as it is. Then we change. We change subtraction into what again? Addition. And now we change the negative 4. What's the opposite of negative 4? 4. Positive 4. Okay, now we're coming up against a situation where these are different signs. So I'm going to write that down. They are different signs. So remember, when they're different signs, essentially it's like, hey, I've got 5 greens. Or 5, well, you know, I've got 5 negatives and 4 positives. Which one do I have more of? More negative or more positive? More negative. How much more negative do I have? 1 more negative. So this is a negative 1. You are subtracting and keeping the sign of the larger number. So negative 1. Okay, I just wanted to go over addition and subtraction rules real quickly with you as a refresher. Go ahead and get this copy down. I'm going to leave it up for another 30 seconds. And then we're going to go to page 4. You're going to try a couple problems on your own. Page 4. What I want you guys to do. Shh, EJ. Lovely singing voice, but please don't. What I want you guys to do, I'm going to give you just 4 problems. I want you to try and do them without the calculator, but then use your calculator to check. Try and do them following the rules without the calculator, but then use your calculator to check. So negative 7 plus 2. Negative 4 plus negative 5. Eight minus negative 4. And then negative 9 minus 2. Try those 4 problems without the calculator first, and then use the calculator to check. Good counting again. There it goes. Let's go ahead and go over these real quickly. Negative 7 plus 2, you should have gotten negative 5. Negative 5. Remember, this is an addition problem, so you follow the addition rules. Since they are different signs, you essentially are just doing 7 minus 2. And because this is a negative, your answer is going to be a negative. So it's negative 5. Essentially, you're just subtracting and keeping the sign of the larger. Yes, that's thunder. Quiet. Number 2. Number 2, we've got negative 4 plus negative 5. They are same signs, so that means you're just going to add them together and keep the sign. You're just going to keep the sign. Guys. Y'all act like you've never heard thunder before. Come on. Number 3. Number 3 and number 4, because they are subtraction problems, you're going to follow the rule of keep, change, change. So you're going to keep the 8. You're going to change to addition. And then you are going to change to a positive 4. Y'all, seriously, some of you are starting to get on my nerve. You're going to add these together, 8 plus 4, and that's going to equal 12. Number 4, subtraction, so that means you're going to keep, change, change. You're going to keep the -9, just as it is. You're going to change. Subtraction becomes addition. And then you're going to change the second number to a -2. Then you follow the rules. Hey, they're the same sign. So you just keep the sign as it is. It's a -11. Okay. Now to get into what you are actually going to be doing today in your assignment, which is the word problems. Identifying how to solve a word problem. We're going to do 2 examples, and then I'm going to let you get into your IXL. You'll have today, for the remainder of class time, to work on your IXL. And you'll have 10 minutes at the beginning of class tomorrow to work on your IXL. So for word problems, for our first problem, we've got Mount Everest. Mount Everest is the tallest mountain in Asia. Mount Everest is the tallest mountain in Asia. It is 29,028 feet above sea level. It's 29,028 feet above sea level. Then you've got the Dead Sea. The Dead Sea is one of the lowest elevations. It's a sea. The Dead Sea is at 1,312 feet below sea level. Guys, there shouldn't be any need to talk right now. (1,312 feet below sea level. I want to know, what is the difference? What is the difference between the elevations? Okay, so right now you should be thinking, what operation? You should be thinking of what operation does difference mean? So who can tell me what operation is the word difference? What is it? Subtraction. Okay, so the word difference means that you are going to be doing a subtraction problem. We are going to subtract the 2 elevations from each other. Okay, you're trying to find the difference between these elevations. You are taking the subtraction. You're finding the difference between them, so you are subtracting those values. So we are taking 29,028 and we are subtracting. Now, I know that 29,028 is positive because of what? What word lets me know that it's positive, EJ? Above. Okay, the fact that it's 29,028 above sea level lets me know that this is a positive value. Now, what about 1,312? Is that positive or negative? Negative because of what word? Below. Below lets me know that this value is going to be negative. So when I'm subtracting I'm subtracting a negative 1,312. Common mistake that people make is that they just put subtraction and they don't put the negative. That's a common mistake and it's a big one. Don't let that happen. So we are subtracting 29,028 minus a negative 1,312. Again, you're going to have calculators. Get used to using them. That's going to come out to 30,340 feet. So the difference between the elevations, you've got one that's starting below the level and one that's way above the level. You have to rise to level first, then keep going to the above level part. All right. In Denver, Colorado, the temperature, some mornings, you know, Denver is really, really cold. Oh, yeah. We went and visited over in Colorado a few years back in like late June, and it was still snowing. It's because of the climate, and it's because it's higher elevation. It is fun. All right, so in Denver, the temperature in the morning. So it's really, really cold in the morning. But we'll say, you know, let's pretend it's really, really, really cold, and it was like negative 18 degrees Fahrenheit. Okay, so in the morning it's negative 18 degrees, but then by the afternoon it's going to rise 12 degrees. Shh. Some of you are still talking. By the afternoon, the temperature rose 12 degrees. So I want to know what's the temperature now at. So before you try to answer, first thing you need to figure out, tell me what the operation is and how do you know? What word or phrase lets you know what kind of operation we are doing? Are we adding, subtracting, multiplying, dividing? EJ, what do you think? Adding. And what word lets you know that? Rose. Okay, rose, it's another way of saying increased. It went up. It climbed. Right? This is going to be an addition problem. We are going to be adding. So you take what you started with, right? What did we start with? We started with negative 18. And then we increased by 12 degrees. So what is our new temperature at now? Go ahead and in your calculator, you should be able to type in negative 18 plus 2. Negative 6. I know.
You said 16. No, you said 16.
You did say 16, but I know you meant 6. All right. That is it for our notes for today.